everything has been super interesting. I'm learning a lot, and I hope that the visitors and the customers are learning from Henkel as much as we are learning from everything. The software, the semiconductors, the integration of everything has been a super comprehensive show. So Henkel, we have two key divisions. One is on consumer and beauty care, and maybe that's the face of Henkel that is most known for everybody. But also we have half of our business is focused on adhesive technologies that cover different industrial industries, applications, but that includes automotive. So for the last 10 years, we have dedicated teams from applications, R&D, commercial teams, developing the products and putting the portfolio better suitable for the ADAS applications. So that includes the sensors, the control units, the computing units now with the new architectures. So we are here to improve the dialogue and the communication with the ADAS players. Well, ADAS is about primarily reliability. Any degradation or problem of reliability in the component can be catastrophic. It's a safety component. So the choice of materials can bring the optimum reliability, the optimal design for that reliability, the lifetime of the part. So we have different technologies from thermal interface materials to avoid a hot spot in the part. We have encapsulation adhesives to avoid some solder joint degradation because of thermal cycling, thermal shock or vibration in the automotive application. We have solutions to provide robustness for electromagnetic energy, so avoid the noise or the interference cross talk of the component. So a lot of the reliability performance depends on the right choice of the material. That's from the reliability perspective. There's also the side of the manufacturing and processability. So we see mass production and higher volumes coming to ADAS, to radar, ultrasonic sensors. So our materials need to have the right dispensability, processability, fast throughput, shorter process cycle, and other metrics like sustainability, energy consumption, CO2 emissions. So all that is not evident, but all that can have the influence of the materials. Here, for instance, I have the teardown of a camera, a near-range camera. And inside that camera, we have different materials. One key material is the active alignment adhesive, the active alignment glue. And for the last years, the best approach from the automotive industry is to have a dual cure material that can have the active alignment position fixed by UV radiation, and afterwards have the full cross-link polymerization of the glue with a thermal cure process. So part of the innovation from Henkel is to present, I think we launched the product in the last AutoSens in Detroit a few months ago. So we have this Loctite NCA01 UV. That means that only with UV curing, you can have all the properties, the automotive properties of high glass transition temperature, low CT for the automotive camera, the automotive LiDAR, any optical part that needs this active alignment application, only with UV light. So that brings a lot of benefits. First, for the reliability, because the material have good dimensional stability, so no degradation in the properties, and also the process cycle. So by cutting the heat cure process, you save your energy, CO2 emissions are related to that, but also the customer can have a release of the footprint of that real estate of the thermal cure machine, and they can invest in more active alignment stations, have mass production levels, and a faster throughput. So all that can have the enabling part from the materials. So that's one example. Another technology is thermal interface materials for all the optical sensors, like the LiDAR, like the camera. There's a concern of outgassing, fogging effects. So we have silicon-free materials that have a very good thermal interface performance for thermal conductivity above 4 watts. We are also developing a 6-watt material. And there's no concern from the outgassing or the fogging from the optical part. So that's another aspect. Another part could be underfilling for protection, full capillary protection of the component to robust the solder joints. And perhaps a fourth example can be EMI robustness. So we have dual function materials like thermal and EMI absorption materials for the radars. If the configuration of the chips are bringing some higher electromagnetic energy, by this material we can first dissipate the heat from the chip and absorb as much electromagnetic energy as possible. So these are some examples of how the materials can bring the influence for the ADAS component. Preferably at the earliest stage as possible. From the design stage, A sample, B sample, it's better to cooperate and to define perhaps even with our established customers, the material has been working for the previous generations of the component, may not be the right material for the next generations. One example is the introduction of more capable SoCs with the same footprint but more processing power. So your power density is increasing. If you were using, let's say, the previous generation of thermal interface material, it makes sense to exchange from an early stage in configuring the gap of the design, the right thermal conductivity. If the component is going to be mounted vertically, then vertical gap stability from the material. So that is beneficial for everybody. For us to react and to present the right material, sometimes to adapt the formula or bring in a new advanced development program suitable for that application, for the market, and for the customer as well. All the investment in R&D, engineering resources that are put into the project is better to invest at the right time. And if not, we are here at the show to engage with other ongoing projects. Maybe the customer is interested to have a second alternative of the material, give it a test. For that, we also have a series of laboratories in all the regions, North America, Europe, Asia. Here in Europe, our best resource is the ICT in Düsseldorf. It's the Inspiration Center in Düsseldorf, where all the technologies are located. So we invite our customers to work together, do some test, trial, and prove that what we see in the laboratory will be translated to their production, to the component. So it's a full round cooperation with the customer.